Hey guys, welcome to the greatest week in the data center, calendar year. This is my favorite week. This is the week of Data Center Anti-Conference, or DCAC Live. Thank you for making the trip. You guys, first of all, why don't you guys do me a favor, introduce yourselves, and then I'm going to ask where you guys came in from, and then we're going to roll right into some cool power stuff.
I can start. So my name is Carsten Schrick. I'm the general manager of INNIO Jenbacher North America. Our headquarters is in Houston. That's also where I live.
Nice. It's a very
so it was an
native
easy drive.
Houston accent. Yeah.
Yeah.
I got you. How about you, sir?
Thanks for having me. Thomas Seeber came out of Austria, out of the mountains directly. We have some snow up there, so looking forward to have some sun now in Austin.
Yeah.
I'm globally responsible for data center applications.
Really?
And as well responsible for half of Europe for the global Jenbacher business.
No kidding. So a lot of unpackaged. Both of you guys, thanks for coming in. As you can see, there's three phases of this conference. It's focused on people, power, and capacity. You guys are power and capacity, right? So this is a really exciting time because you're the data center expert. I've been in the data center game for a bit, and we're just now finally meeting, right? Don't know you. I don't think you knew me. But it's a real testament to how our two industries are on a collision course right now. The product of the data center is now also including power. There was a time where we only made a type of data center for the World Wide Web or the Internet of Things that really it wasn't so network sensitive at the time. And then eventually it became incredibly network sensitive as we built cloud data centers where the product became connectivity as much as the space, the power, and the cooling itself. Now the product is evolving yet again with AI data centers, and the product is space, power, cooling, connectivity, and more power, right? So for us, we're having these conversations for the first time. And INNIO Jenbacher, first of all, how long have you been there? Tell us a little bit about the company, because I want to go back into how established this brand is. And I know some of the history of it, but I want to share it with the other people that don't know. And then I want you guys to help us explain to them exactly which altitude and airspeed you guys play at in terms of the product that you build. Can you do that?
Definitely. So Jenbacher is a pretty old business, but the Jenbacher business itself was not in principle for power generation. It started with metal productions, I would say in the 1950s, but then was a slow transition then as well we first started producing diesel generators.
Diesel generators?
No, this was the 70s, 80s. And then at the end, we, especially for the rail industry, mainly in Germany and in Austria. And then we have been transitioning by ourselves to say we wanted to be in a niche, and as they started to getting a little bit more decarbonization already at that time. And then we are focused on a special niche, which is gas engines, which was pretty new at that point in time.
How long ago is that?
That goes back. So
early 2000s?
That's in the 1990s.
Okay, so before the
late 80s, beginning of the 90s, we have specialized heavily on gas engines. And then we, over the time, brought out then various, let's say, world-leading technologies with having two-stage turbocharged system combined with the highest brake BMAP pressures, where we really have been going to low power density and have been the first ones as well bringing out the 3 megawatt gas generator back in the 2000 years, and have been slowly evolving over that time and improving in various fuels which we're going to burn. We can talk about that later, which fuels we can burn. But our main fleet, and that's very interesting, the main fleet of Jenbacher, Jenbacher has roughly about 26,000 gas generators installed globally. More than 50% are running on a renewable fuel, for example, like biogas.
Biogas, why that one?
We have been coming big in Germany, for example. In Germany alone, there's a lot of incentivization about the biogas. If you're really using biogas for power generation and then injecting it into the grid, which helped a lot to evolve the industry in Germany as well with decarbonizing at the end the natural gas grid by itself. But at the same time, biogas is not only injected into the grid, it means in the natural gas grid, it's as well used for power generation. At the end, it's a decarbonization. It's a net zero game. And more than 5,000 units only in Germany run on biogas.
No kidding. So shifting to you, how long you been with the company, and did you come over here as Advanced Recon and set up headquarters or help establish a front range?
Thanks for asking, but I've been in the power gen business for over 30 years. With Jenbacher, I'm only there since 4 years now. Was with other OEMs.
Was Jenbacher spun out of GE or something like that?
Yes, GE.
It was, right?
It belonged to GE until 2018, and in 2018 we were bought by private equity, Advent International, which we're belonging still today. I'm leading the show here in the US since 2021. And of course, the big focus right now is data centers and municipalities also, because there's a power crunch in the grid. So it's not only data centers which experience
You're
problems.
helping the
there's
utilities
also
and the utilities' biggest client.
Yeah.
Yeah.
But coming back to Thomas' point, it's also how Jenbacher started in the US. We started on biogas, on landfill gases, wastewater treatment. These were our first projects in the 1990s.
Interesting.
And then it was transitioned to natural gas, I would say only in the late 2010s.
Is that what a majority, you said more than, you have 26,000 engines out there and about half of them are natural gas now, or is it biogas? Is that what it was?
I would say half of them roughly.
Yeah.
Half. It's not only biogas, it's renewable fuels. It can
Renewable fuels.
be any fuel.
Are the rest diesel then?
We have no diesel fleet
Really?
anymore. So this is, let's say, history. So we are not serving any of those diesels which we have, let's say, brought into the market. So we have especially focused really on natural gas. So there is not even a diesel product anymore what can be purchased from us.
How did what was the intent behind that pivot, where you became really focused on data centers? When did that occur to you? You're the data center market leader.
Yeah.
When did you realize that, hey, there's an adjacent industry to the utility providers that is in a massive growth spurt, and you had to get yourself really engaged in what they are asking for from the utility provider?
Yeah, it was a slow process. So let's start that way. So I'm with the company since 16 years now. Since with 60 years, and out of the last 5 years, I'm heavily following the data center industry.
Okay.
Mainly driven by the fact that there have been always cases as well that the data industry was as well always open to innovation.
Sure.
And as we all know, in the industry, the traditional way how to build a data center should kind of stay, but it's always evolving. And if it's changing, then it's fast-pacing changing. But at the end, the most important thing is power, right? At the end, the grid should not get off, or the power should not get off. Reliability is one of the, let's say, key elements. And there was the first time when I come across that, because I said, look, we have a fleet of such a big amount of gas engines. We know what we need to do in terms of reliability, the power is stable. But then there have been the first thing, I think 6 years ago, the first interactions where there have been certain regions where the data centers are not getting the connection to the grid anymore. This is going 6 years back. This is heavily evolving since that time. And at that time, 6 years back, we've done our first installation, a 60 megawatt project in the US, where we could support our client, supporting him really to get a grid connection, because he has a behind the meter on-site power generation plant, which he can dispatch and connect back to the grid if required, or could curtail load. So this was the first interaction where we said, this makes a lot of sense. But there was a but. A standard gas engine technology can't handle that. So therefore, we had to find a solution together with that client, and we developed certain products in our portfolio which are explicitly serving those markets now since then.
Is Jenbacher strictly in like the reciprocating engine side, or do you get into turbines?
No, we're exclusively on the reciprocating engine side and gas only.
Gas only.
The turbines is a competing technology from time to time in several projects. But no, we are exclusively recip and exclusively gas. But you could also say nearly all types of gases. If there's a certain heating value in the gas, we'd probably be able to burn it. That's our specialty.
Okay.
And just to add, even without heating value, we can do it at the end, right? Therefore, because we have already very interesting hydrogen installations out there. Hydrogen installations as well for data centers. In Netherlands, there is a use case where we have installed a 6 megawatt backup solution, which is actually a dual gas installation, where the client can decide to run on 100% hydrogen or can run on 100% natural gas.
And is that a primary generation solution, or that's a backup?
It's a backup
to utility.
It's a backup to utility.
And what's the utility providing for the main force of? Is it natural gas on the utility side already?
It's in Netherlands, so it's a grid connection. The grid is pretty decarbonized in Netherlands already, so it's a lot of renewables there. Especially this renewable add to the grid makes it, I would say, to a certain extent, all pretty volatile. That's one of the reasons why in certain parts of as well in the US, right? But this is a global trend where the grid is getting to its limits, and therefore the grid connections are not going to be permitted over the next years. But this was not the reason for Netherlands. Netherlands, the client took the decision. He wants to be the first one having a hydrogen gas backup solution totally decarbonized in Europe.
So what was the genesis behind that demand? Because it looks like the application of technology that you arrived at was driven based on something in Europe, not something that we're seeing in this industry. But it seems like it's a parallel. What you saw was a strain on the grid, right? And there was a capacity concern on the grid, and simultaneously, while trying to solve for that capacity problem, there was a sustainability or reliability sort of efficiency standard that had to be maintained. So it required a lot of creativity. Is that right?
Exactly.
And then how did you realize that pattern, which is coming back full circle again, but it's into another industry altogether? How did you realize that you've solved for that already back in another place? And in what capacity can you continue to scale that solution at?
So in terms of capacity, so far we have not come to our capacity limits because we are, let's say, working together with the clients and see what is the demand, what they are going to get to. We have opportunities to expand our production capabilities if required. I would say not within 1 week, but if we know it, if we can plan for it, we are ramping that slowly up.
Where do you guys build? Where's the manufacturing plant?
In Austria, Jenbach.
Okay.
But
then
coming back to Thomas' point, is also normally the data center is also built in phases. So it's not always 500 megawatts in one go. It's normally phases of 50 to 60 to 70 megawatts. And this we can accompany. And this is what we're trying to find out together with the client. What is the production schedule we need to attain to in order to make it happen for you? So what's the end date for commercial operation? And based on this, we will expand production capacity. If we have more than we can chew on projects, we will try to expand, or we will expand. Of course, as Thomas said, it's not going to happen overnight. It's done with careful planning, because with careful investment, but we're willing to do this. But right now we have not reached our production capacities.
And the good thing is we have as well a facility in Wisconsin, in Waukesha. So we have part of the INNIO Group. There are 2 brands, Jenbacher.
Oh, so you have a
Waukesha.
partnership to build with up there too. Okay.
Exactly. So in principle, we are already under the evaluation, and we are more than eager to do so, that we bring the technology, what we have, what is currently manufactured in Austria, that we bring it as well to the US and maybe set up a production line solely for the US if the demand is progressing in that area, what we're seeing.
Well, what do you see for demand? What are you anticipating happening in this industry? I mean, I can imagine you can make a business case just to justify the demand of what the growth looks like in the state of Texas alone to justify putting a factory in the United States.
Definitely. So if you look into the AI data centers, we're talking about 1 gigawatt, 1.5 gigawatt to 2 gigawatts soon.
But that's not it. That's per year, maybe first year or two. I mean, I'm involved with 3 different programs that are using
it's per project, what I mean.
That's what I'm saying, is there's so many of them.
There's so many of them, exactly. What we see as well, a parallel, this trend about the nuclear discussions. I think we all maybe have seen it, what Microsoft just did just recently with the announcement of the 3 miles nuclear plant. So I think this is showing let's say how desperate everybody is to get power, right?
Yes.
So therefore, I would say so we are more than happy to double our production capabilities over the next 1 to 2 years. We see the trend that that the projects are moving to 1 to 1.5 gigawatt. Still, they are a little bit out, but the planning starts now, right? In 2-3 years, this is a totally different ball game. So therefore, what we see in terms of demand, we are talking now about potentially use cases that maybe 500 to 600 to 700 3 megawatt units from us might be required over in maybe 2027 or 2028. And we are going together with the clients. We are developing that.
At that volume of scale, what is I mean, for those that are listening, maybe for the first time, walk people through what the product is itself, right? Because like I just did a podcast with VoltaGrid, and you guys have an association with VoltaGrid in some capacity, I'm sure. What does that relationship look like? Because that's the same as probably the same relationship you have with our Power and other groups that are along those lines, right? So help people that are listening understand what's the difference. You guys actually are producing the engine itself, and you guys are, and then other people are taking those engines and then selling it as a service, where you're selling it as a product, right? Explain what the product is. What's the building block size? Because when we're talking about gigawatts, right? We're talking about gigawatts of need on a campus. And I agree with you. We're going to be, look at Quantum Loophole. I just used them as an example in the last podcast. They're taking down a couple thousand acres at a click, and they're going to build a very urban campus of, hyperscale AI data centers that people will live within those ranges, and everything's going to be kind of plugged in. But there's only so much power, right, I can put together in a certain capacity, right? What's the size of the building blocks that you're going to build at, and how many engines does it take to get to a gig, and I'm talking on the reciprocating side, because that's a lot of engines, right? And again, you may be adding them, so 50 megs at a quarter, 50 megs at a month, perhaps, who knows? But regardless, we're going to get to the G's, right? And you have enough engines out there now, that you could quantify how many gigawatts of engines you probably have, right? So probably 13 gigs of power or more. I don't know, but arbitrary example. But what I'm saying is, what are the size of the product? What is the product? Is it just one size fits all? Do you guys have different things? Give us some ranges, and then help us figure out how we take that product and we solve for the capacity problem. Because there's 3 problems: capacity, people, and power. And we got to solve for people to solve the power problem, to solve the capacity problem. There's a lot of stuff going on. And I think as the blocks themselves get bigger, I think as the campuses get bigger, so does the blocks of power, right? And if you're not getting into turbines that can get, 18, 30, megs at a click, what does the block size look like? How would you solve for 50, 60 megs at a time if the engines are this block size? You need, so many of them. And what's the application look like? Can you stack them? Can you, what are you doing? Ring bus systems with all this stuff, So walk us through what your product is.
Maybe I'll start, and maybe Carsten just provide a lot of questions, but let's start with the first one. So the first question was about VoltaGrid R-Power and what is the role of Jenbacher combined with R-Power and VoltaGrid. So at the end, Jenbacher is the OEM, manufacturer of the product itself. It's it's an internal combustion engine and a RISE engine, very similar to a diesel generator, I would say that way from a technology perspective, but running on gas. I would say that's a high-level overview how it is. In terms of size, similar size like a diesel generator, if you compare it on this, for example, in a 2 or 3 megawatt node. What VoltaGrid and R-Power are doing, they're taking our product and moving it to a service. So the equipment can be purchased from us, from various clients, and we are partnering up with VoltaGrid and R-Power that they can provide a solution, bridging solutions, services, energy as a service solutions for clients who do not want to directly purchase and make capex investments. So we're teaming up a lot with them, and the good thing is those units, I would say most of them ending up in containerized or trailer-mounted packages, so they can be transported from A to B in a decent amount of time. And that's leading to this other question, what you just said about the power nodes of the products what we are having. Obviously, we start with 200 to 300 kW as well. We have products as well in that range. But we have as well a product which has, for example, 10,000 kW. So we have a 10 megawatt product as well. And we have something in between. So 4.5 meg, 3 meg, 2.5 meg. In principle, we can serve every range in that regard. But there's one part, the bigger the product gets, let's say the more complex it's getting to handle, right? You need to transport, you need to get it to site. You're not getting it on trailer mounted concepts anymore. So therefore, what we have so far seen is the best fit is either a 3 megawatts, and now we're moving, or as well 4.5 megawatt solution, because the power density is still compressed. You still get easy road permits. You can still transport everywhere. Electrical efficiency is still pretty good. And the major point is the technology difference, because the bigger of the engine size it's coming, it's the same problem what we have with gas turbines. We are seeing a different pattern in terms of load behavior of the data center, and as well response of the product which we are developing, that we need to be within the adequate power quality levels, frequency deviations and voltage deviations. And therefore, we have specialized on those models, 3 megawatts and 3.5 megawatt, that we can replicate the same performance like a diesel generator. So that means the clients do not need to worry, even if we talk about AI loads going forward or spiky loads.
I was like, are you sure?
That we can handle that. So we are doing modeling. We are already at that stage that we are having done first tests and as well in simulations with clients to really see what we can do that we can fulfill the demands. The biggest problem is the following. Nobody knows to 100% how the AI load is going to look like in reality. There might be some exceptions, but this is just kicking off. But this is a continuous progress. And the good thing is, as we are supporting that and we see already the fleet out there with VoltaGrid and with our power, with our units, we know exactly what the load profiles are look like, and we can try to optimize our performance, especially for those needs.
All right. So listen, let's talk real quick about how that stacks up against a gas turbine. Like, what are the advantages of reciprocating over gas turbines? I mean, I know a few of my own, but you're the ones that are looking down the barrel of what the alternative option would be. How do you continuously offer a better solution to that?
Yeah, first of all, I mean, there are a couple of things on the top of my head. It's first of all, start times. We're much faster starting up the engine, reciprocating engine. Then we don't have any or much more less derating due to altitude and due to temperature. We have cases where we don't even derate at 120 degrees F. We have engines for that, or we design them in the way. Then, of course, load application rates. We have much higher block load capability than a gas turbine. And, of course, efficiency, right? The efficiency due to the derating, with the recip engines, you always get the nameplate capacity, right? With a turbine, you always don't get it, right? You always pay more for what you need.
There was a guy that was just on, he said there's the only two efficient modes to run a gas turbine is 100% fully loaded or off.
Partial load is not
it's
the way
horrible.
to run. Mm-hmm.
So let's talk then about how that product itself, which you created to make a more sustainable product that gave more capacity to the grid, where does it stand on reliability, right? Knowing that the product is, when I say the product, let me back up and see if I can explain it, because we are two separate industries and we are merging the way that our two industries are coming into parallel with each other.
Mm-hmm.
There was two adjacent orbits, and now we're kind of in orbit with each other. And there was a time with the product when we first launched the internet, which the product did not include a heavy focus on connectivity, just enough to get me back to a carrier hotel. Now connectivity became a big part of the product. Now operators, very sophisticated operators, some that were publicly traded mission critical REITs that are all privately held now, they have massive pressure to go out and deploy as much IT capacity as possible. Simultaneously to that, they have to solve for power. They used to be able to go get a PPA or a consultant to go lead them through this specialty phase of a program to where someone would go out and get them secured rate tables with, economic efficiencies behind where they were getting their power. And now the utilities, I saw multiple different reports where there's some states that have a couple thousand, grid connection requests in them. There's too many grid connection requests to count. I mean, Manhattan has as many, the city of New York with the 5 boroughs has as many grid connection requests, 5 times as much power grid connection requests than they currently serve, right? So there's so much demand for power, but people are asking for power, and there's a lot of overlapping requests. 3 different operators in the same market pursuing the same client are each putting in a grid request, but only one of them will win, right? So the product became the power with it. So soon, these privately held companies are going to have to solve for a way to deliver space power, cooling, and I mean power from a distribution perspective inside the building. But now they have to make sure they have all the latency requirements necessary to support the cloud or compute environment they need. And now these operators even have to start building their own substations and their own utility plants, basically. So now the data center operator creates a primary generation plant, which converts them into a utility provider in essence. And how big does that scale? Like, how many of your clients today are utility versus like the data center? Like, is there a plateau where you have a 10 megawatt reciprocating block? Is there a plateau that you reach where now you have to worry about regulation in that market where you can only have so many particulates per region of geography? What are the things that are limiting this massive adoption, do you think, of this technology?
So a
lot of questions.
In principle, so what we just on the client base, so for us, we so we are just growing now in the data center industry, right? So we are coming from the classical ones. So we are used to deal with municipalities, for example. So we are used to deal with plants which need to run 24/7 because we're coming out of that business, right? In all of the world. So it's not only in the US, it's in Europe, it's all everywhere. So that means, so we know exactly what we need to do in terms of emissions as well to be compliant with all the regulations in that time. We have experience on that, and we have proven that over the last years already. So therefore, alone in Germany, just coming back to Germany, because we do a lot with municipalities as well in Germany. In Germany alone, I think we have, 7 gigawatt installed for municipalities only.
Really? You guys are doing gigawatts of reciprocating engines just for your municipalities?
Exactly, yeah.
Dang.
They have a little bit of different purpose, maybe just short. I don't want to go deep in that, but we as well, what we can do as well, they need a lot of, let's say, they have a district heating network, and we can generate heat as well with our engines. It's a byproduct because out of the exhaust heat of the exhaust gas heat, for example, or the heat of the coolers, and we take that heat and then heat up the district heating water. We could use that as well to provide cold water with absorption chillers if that is something interesting as well, maybe for the industry for cooling, which is, let's say, one of the options which can be helped, which we can help as well for including cooling in our complete solution program, and maybe reducing the BUE or the energy efficiency usage of the data center. But that's maybe a next step, right? But if you say, what is the sweet spot between, so with 10 megawatt or 3 megawatt units, an example in just this year, we have closed a project in the UK with 450 megawatt with 4.5 megawatt units, right? We have done projects with 10 megawatt units, which are only 20 to 30 megawatt. So it always depends a little bit what is exactly the need, right, of the client. Because it's not necessarily mean that a big engine means this unit should be used for a big power plant. No, that's not the case. It really depends what is the use case and which product fits the best benefits.
Based on reliability?
Based on reliability, based on redundancy.
Yeah.
Based as well on efficiency, and as well based on performance in terms of, for example, load changes.
Oh, I got you.
And also not only reliability, also operation profile. Is it used for peaking? Is it used for base load? So there's tons of different applications, and let's call it, as Thomas said, there's a 100 megawatt plant and it's used 2,000 hours a year. So there might be a total different solution than for a data center where we're replacing the utility or the grid, which runs continuously. So there might be a totally different solution. Right, because you have to think of emissions, you have to think of loading rates, and then suddenly, as Thomas said, what we sold in the UK, 100 engines in one spot is not a problem, right?
Yes.
And the good thing is, and that's one of the beauties, we have the complete range, and that makes it a little bit unique. And I really need to say that because that's a unique positioning. What we have is we can decide and we can offer solutions, and the client can decide by himself what makes the most sense for him, because we could offer the complete range and are not bound to this is the only product what we have, is right. So there are various options. Obviously, we guide our clients. We go through that process together with them and finding, based on their real needs, what is the best product which fits their needs, right? And that's
I do think that there's a lot of value that we're getting from your experience of working on the grid and the interconnections to the grid, and how that's going to parlay into what we're trying to do as operators. When 5 years ago, when you started paying closer attention to data centers, what was your thought at that point? And did you see yourselves getting into the data center game at that point, not for primary, but as backup?
Yeah.
Really?
So at that point in time, even I would say 2-3 years back, we would have also thought that our game might be backup diesel replacement.
Yeah.
But the grid constraints, I think, have overwhelmed all of us over the last years, and not only in the US, but US is pretty dramatic at the moment.
Yeah.
But I see it everywhere. I see it in Ireland. I see it in Germany.
Yeah, of course.
We have a lot of
wherever we're building lots of data centers.
Exactly. In Dublin, 25% of the data center power consumption, 25% of the grid is only consumed by data centers.
Yeah.
With a lot of installations there as well. It's a very similar to the US as well. In Ireland as well, we are running the data center in peak times on our power generation plant, 60 megawatt, 100 megawatt, whatever it is, because the grid is not yet that unstable that they are not giving grid connections, they have made a ban. But they still have given let's say a certain amount of grid connections during the time. But in the US, it's now really pressing. You have waiting times 7 years, 10 years, right?
Yeah.
And therefore, there needs to be a solution for that. And I think, therefore, this combination, this partnership with VoltaGrid, with R-Power, and all the others out there, where the client has the option either to go directly and own the equipment with an investment or go with a service solution, is making it, I would say from that perspective, a balance sheet game at the end, right? What makes the most sense for him, because the performance we can assure it's going to work out with our technology.
I got you. Yeah, it's whether you want to take out your money and go buy a house or if you just want to lease it. And that's the difference between what those other groups are doing, right? So what are you preparing for right now? It sounds like you have invested heavily into the US data center market.
Well, if I might add to what Thomas has said, when I started with Jenbach 3 years ago and started to form the team here or modify the team, I talked to my sales guys and I said, there must come a point in time, looking at the data center market and data center spaces, there must come by the way they're building, there must come a point in time where the grid cannot supply anything anymore. And we started to work on this 3 years ago, reaching out to the customers, etc. Do you think we need to replace the utility or the grid? Are you interested in these things? And of course, at that time, everybody said, no, we can connect to the grid and we just use diesel engines. Well, 3 years later, the situation has changed 180 degrees. More or less, right?
Yeah.
And it started, I would say, 2 years ago, where the first engineering companies came with, can we look at this? Can we look at that? And as an additional example, we have one client, for example, where he said, we talked with the client and he's building quite a large data center on the 400, 500 megawatts. And he said, well, Jenbacher, all nice and fine, but I need an engine replicating this capabilities or this quality. That discussion was in April. And in December, we have that engine on the testbed. And that's pretty unique for a company, for an OEM.
Versatile, agile you are.
So we are going together with that speed which is required, right? So we are even though we are, let's say, not a small company, but we are running the business still. I would not call it a startup, because we are,
Aren't you the biggest natural gas engine provider in the US or in the world right now? Who's bigger?
We are, I would say, definitely, so we are leading in the market space of natural gas. There are others out there. For example, there's gas turbines out there as well, right? But if we talk about reciprocating engines, yes.
Yeah, that's what I'm talking about. Yeah. Okay, and you're investing heavy in the data centers. This conference is been a really great opportunity to really highlight how much and how significant power is to the existential threat of our game. You know, I always tell people, I said, since we shifted from, I don't know what it was like in Germany or Austria, but in the United States, when we used to have cell phones or smartphones in the early days, they actually charged us by the minute.
Yep, I know.
Okay, and then all of a sudden something happened, and all of a sudden we started charging by the data, right? And it was all a data usage. And that was a time in which we felt like there was no limitation, really. I mean, no one really ran out of data. But now we're getting to the point where the only thing that fuels the capacity for data is now truly energy and power, and we're running into massive constraints across the board because the adoption rate of emerging technology is off the hook. And now we're running into situations where if we don't solve for this, in the next 5 years from now, we're going to have to go back to consumers and let them know that there's limitations of how much cloud they can have, and a lot of data. There will be a technological regression. If that happens, people will actually stop using the cloud as much. It'll be less prevalent, right? Because we've hit our limits. But you guys in groups like yours are trying to solve for those interconnection grid capacity challenges. What are you doing to get ahead of it? What is INNIO, what is Jenbacher doing, INNIO doing right now to get ahead of that from it's not always a product thing. Maybe it's a staging thing. Maybe it is a manufacturing thing. Maybe it's manufacturers' reps that represent your gear as a distributorship would be in different parts of the market, so you have a greater range. But what are you doing to take on the market, at least in the United States, with regards to data centers? Yeah,
what we do is, so at the end, there are not many options, right, at the moment, right? So the options which are there, because it's not small scale. At the end, it's getting bigger and bigger. And therefore, as mentioned before, we are working together with our clients to come up with an individual roadmap on their planning perspective, that we are ready for the capacity which they might need in 2-3 years. So we're not only talking about now, short term, so we're developing that together with the client. In parallel, we're not only talking, at the end, it's not, we as well at the same time talking to municipalities and the grid operators what we can do to stabilize the grid, right? So this is not only a discussion with the clients means data center clients, this is as well a discussion with the individual grid operators to see and participating as well in standard tendering processes where we are trying to support other clients, not data center clients, but other clients which help to stabilize the grid, which at the end has a benefit as well for the data center industry. So we are tackling in principle the complete market. And that's as well, Carsten, maybe you can explain one of the other, especially in Texas, right?
Yeah.
What's just going on there, especially with all the ERCOT discussions, what we're going to have and what tendering process is just out there.
Yeah. No, agreed. It's not only the data center itself, it's also the grid got more unreliable over the last couple of decades because of adding of intermittent renewable capacity. The market was a thermal market, a hydro market, and to a very small extent 20 years ago, solar and wind. But that has also changed. So we have much more solar and much more wind when I look at all the regions, California, Texas, etc. And the problem with this is, or the challenge with this is, the wind doesn't always blow and the sun doesn't always shine, at least 12 hours a day.
Yeah.
Right? So, and the grid is relying on this generation capacity, and suddenly it isn't here. So in Texas, the cure, they think, is to add gas peakers into the market to make the grid back to its original reliability. So the good thing about thermal plants is you press a button and it runs, right? And we cannot do that with solar and wind. So this is also what we're seeing in Texas and other markets, that we're adding capacity of gas generation into the grid to make it more reliable. And this is not, these are 10 gigawatts. For example, right? The projects right now, which are under revision by the Utility Commission, is 10 gigawatts. And they're thinking, well, we probably have to add 130 gigawatts in Texas. And that's Texas alone. And this problem will come to the rest of the market in the US also, because, I mean, Texas is an island grid, but the rest is still interconnected. But there will come a point in time where this is also challenged. So the solution right now is gas peakers, because batteries itself don't cure the problem. They're just shifting the peak. They can store a little bit, and then they can deploy the power which they collected at a later stage, but they also come empty when you buy them, right? The batteries. So you need to fill them up first.
Can't charge them. Yep.
Yeah.
So what does Nirvana look like? I mean, what do you see the solution in the next 5 years? And what do you see natural gas playing in terms of that solution? The bridging power to nuclear is an example.
I think natural gas will play even a bigger role in 5 years than it plays now.
Really?
I would say, depending on how it progresses. So if that, let's say, progression and planning of the DC clients are going to be pursued as it's currently planned, I think the problem is just getting bigger, right? So we can't. We all need to be, let's say, frank with each other that this is going to happen. The good thing is, and that's the real good thing is, I think the parallel discussions, and I think that's for me okay to talk. Gas is a fossil fuel, right? It is the best fossil fuel which gives the let's say the lowest emission levels, and with exhaust after treatment we are coming nearly to zero, right? So we have solutions with our exhaust after treatment solutions that we can comply with the lowest emission regulations. So for us, it's not a problem to really let's say come up with nearly NOx emissions or nearly CO emissions or nearly zero formaldehyde emissions. We can go. An easy explanation for the data center clients, I always use that, let's say, analogy. If you think about a Tier 4 diesel generator, because that's what everyone is used to, what is the emission limits of that, we can be more than 20 times lower than a Tier 4 diesel generator with our gas solution. And that means no matter if it's prime power or backup solution, whatever it is, but this is giving a good relationship, how good we can be in terms of low emissions. And now it comes, and I think at a certain point in time, but this is all future thinking, right? But I think we need to lift that vision as well. And this is something what the clients so far always said, this is very helpful for them, for their industries. We can offer already now that our products can run on a renewable fuel whenever the renewable fuel is ready, when it's available at the required quantities. So therefore, let's come back to hydrogen. I know hydrogen is long out there, right? But I think there's a lot of activities in the US specifically to as well grow hydrogen production. And therefore, we have already proven now at the test bench that we can do the same performance on hydrogen than we do on natural gas. We have even as I mentioned before, we have a real-time case as well, a real-life case in Netherlands where we have proven that we can do it in a backup technology. And this vision is, I think, is a good anchor that whatever is invested now will not be a stranded asset in 5 to 7 years or 10 years. But obviously a second industry, which is a decarbonized fuel, needs to happen as well. But we are ready to take it, whatever how it looks like. If it's ammonia, if it's hydrogen, if it's an e-fuel, it doesn't matter, right? But in principle, it's a preparation for the future. But natural gas will grow, definitely.
Well, let's talk about all the various fuels, right? So it's important for people to understand you have multiple products from different sizes and scales. Are they all capable of running on these various types of fuels? And what are those fuels exactly other than natural gas?
Yeah, so we mentioned we have biogas. So we have renewable natural gas, biomethane, how it's called. We can run on landfill gas, on sewage gas, on blast furnace gas. In principle, any gas which is a byproduct of a manufacturing process. For example, we have as well a lot of installations in South Korea where the byproduct is even hydrogen out of the polypropylene production. And we can use as well that byproduct, which is, let's say, just coming out of the complete process, so process gases, and use that gases to power back the manufacturing plant. So at the end, there is no limit. As Carsten mentioned before as well, as long as there's a certain heating value as well, without maybe no heating value, we can definitely run at any gas what is there.
Now, who are the people that are normally most willing to adopt those types of fuels? Is it a municipality, or are you seeing data center operators playing with the type of fuels that they're using right now?
Classical, I would say it is so far data center industry, not much, right? I think gas is anyhow new, right? So I think we need to be
we're learning how to understand
we need to start slowly, right? I think the first anchor is now natural gas. As well, it's not easy to get biogas at that, let's say, big quantity required, because at the end, biogas as well, you need to have a lot of cows to generate that amount of biogas, right? To burn an engine, to be used on an engine. So therefore, there are some limitations on that as well. But there will be
limitations on some of these products based on economics. It doesn't simply pencil well enough sometimes. One thing that engineers can do is make a technology work. The hardest thing for them to do is to make it pencil out to where it's financially accretive to use it. So what are the ones that are, I love the engineering back of house. There's the development stages and we need that. But what is the primary solution now? Is it just regular natural gas? And that's the largest volume that we're trying to solve for right now?
Well, if you ask me, and specifically concentrate on the US and Canada, I think nothing pencils out compared to the natural gas, what the price is for natural gas, because it's so cheap or so competitive here in the area because it's available as compared to Europe, for example. Here we're talking $4 a million BTU versus in Europe it's 15 or 13 to $14. It's 3 times. So hydrogen has a much easier path in Europe.
Really?
Yeah, because the spread is not so wide for the cost of hydrogen versus
is the capacity a concern for hydrogen? Is there a lot of it, or is it the capacity to make a lot of it?
Yeah, no. Hydrogen, I think this is for the future, right?
Okay.
The capacity is not there, and it will take years as well to ramp it up, because it's infrastructure. It's not only producing the hydrogen, as well the transportation, so as well the pipeline. So
everything's about transmission, just like any other power.
Therefore, I would say hydrogen is not something for the short term or midterm, but I think this vision is just important that the product would be ready to take it. What we see as well, a lot of requests on propane gas as well, where we can run. So, but Carsten is right? Especially in the US with that low gas price compared to other regions of the world. And I think this is going to stay at that level because there is no other choice around that. That is, there is nothing currently. Nothing can be against, let's say, the gas plants. We have as well a lot of the nuclear plants, which are, let's say, phased out over the last years, have been decommissioned because of the low gas price, because they have been not competitive anymore.
Really?
So that is what
natural gas is beating the price off nuclear energy.
Yes.
All right? Well, look, I believe you. At some point, I just need to understand how that does it, what volume, But let's go back to like. This the whole natural gas thing that you guys are solving for. What is the thing that you're doing now? Like for the people that are listening that don't know as much, now they know what the product is. You know what your primary purpose is. What are some of the things that you're doing right now to iterate off of solving the data center problem when it comes to capacity? They're looking for a predictable, transparent, reliable supply chain, right? People that can, like you said, sign a contract for the next 3 years to ramp 50 megawatts a quarter for the next, arbitrary numbers here, but that's kind of how it's going to work. Are you working with them right now on laying out designs for what the best fixed form factor is for a piece of property? Is it, hey, if the best idea is to have 100 acres, arbitrary number, we put a power plant over here, and then we have the adjacent area for X, Y, and Z, and this is how far we're transmitting? Or does that make sense? Have you been working with groups to figure out, one, what does the fixed form factor look like for running primary generation on data centers? And there's got to be a separate one for enterprise versus operator. And then I'll wait with the second question. That way I don't just keep hitting you with 5 at a time, but because I'm going to ask a lot of questions about this stuff. We're going to be able to do this. We'll iterate off this stuff.
Perfect. Ask whatever you want. Ask us whatever you want, right? So therefore, I think the just maybe capacity as well. I think very important capacity on the other side is, I think we can talk a lot and say we are going to ramp up manufacturing. At the end, we are developing the complete supply chain behind us, right? So we are talking as well to our suppliers. Important. To our suppliers, pre-warn them. We are going through that iteration. So it's not only what we do with our clients, where the clients are going to tell us what capacity they need. We are preparing everything behind us, that not only we are giving a commitment that we can ensure that the complete supply chain is ready to take whatever is required, the future capacities there. It's not easy. It's not an easy discussion, to be very honest, because all are just coming back and say, what can you commit to us, right? But at the end, right? Look, if you want to be part of the business, you need to take a certain risk and need to decide on your own, right? So therefore, but that's what we are here there, and that's what we are, that risk we need to take, and we are taking that, and we are ready to take it. And then coming back to what we are discussing with the clients, and it's exactly what you said, right? Can it be different clients, different sizes, right? We all know how it is, right? So others prefer 30 megawatt, others prefer 60 megawatt, others prefer 72 megawatt, whatever it is. So various sizes of plants, but in principle, all of them, we are developing kind of standards for their needs. And this is coming back. It's not one solution fits all, because at the end it will be still different. And the good thing is, due to the flexibility what we are having, and we as well the packaging solutions what we are having, and especially as well together with our partners like Voltagrid and Arbauer, we are so flexible in all the discussions that we can find, let's say, blueprints for a client which he can replicate at various locations. Because he knows exactly that amount of space I need to account for a potential bridging solutions for 7 years, because I'm going to need it at least for 7 or 8 years. And what is a very important topic, and this is happening since 2 years when I'm talking with the clients, is that in their site selection sheets, when we're talking about what are the main criteria to select a new site for a data center solution, it's like gas is now on it.
Capacity to gas.
Capacity to gas.
100%.
Exactly, is now on it. And this was 3 years back. That was not there. Right?
I totally agree with you.
This is not there.
We work with most of the largest data center owner operators in the country, and more than half of my clients are the enterprise end users, and they're all emerging on scene with that question. Everybody that we talk to is really looking. I'd take that back. There's a couple groups that we work with that are so sophisticated. They've hired teams around this already. Like you, they have people like you that they've hired and said, lead us through this, because that's the challenge right now, right? Right now, there's an applicational challenge. One, what is the truth behind your capacity? But the application challenge is, am I only going to be able to use you for primary generation, or am I going to be able to find a use for you to replace my diesels with a backup reciprocating natural gas engine instead. Because I can agree with you that in 5 years from now, there'll only be more natural gas usage, but I don't think it's going to be for the volume of capacity that's going to be required to support AI loads. I think it's going to be to replace, to decarbonize the grid. It's going to be to go in there and all the polluting, aging infrastructure that we've had, we're going to rip out and replace that with your type of product. I think that it's the bridging power for the massive volume of aggregate. We need 45 gigs. We need 45 gigawatts in the next 5.5 years. Yep. That's 60% of that, or 27 gigs of that is going to be natural gas just in the United States alone. And that in parallel takes us from where we stand today at 3% of the total power utilization of the United States comes from data center infrastructure. And by the end of 2030, when we ramp, like I said we would, by then we're at least 9%, close to 1/10 of the total power pulled from the grid will come from the data center industry. And I think that there'll be changes to those things. I mean, the number one consumer for power is residential, as smart appliances and all the things that go into your smart homes continue to ramp up. But again, you wouldn't be able to do that if you didn't have data centers for that data to fall back into, right? So do you see applications, and are you running into operators or enterprise end users, which tend to be the ones that soften up the requirements the most? If you're an enterprise end user and you're building for yourself, you know what you can take out of the electrical and mechanical permutation. But if you're an operator and you're required to build a homogeneous vanilla environment that anybody could go into, you're not removing UPSs yet. You're not removing, generators yet. But if you're a large hyperscaler or a baby scaler that makes purchasing decisions like a hyperscaler, and you're an innovative one, you're going to drop generators as a backup, and you're going to figure out an alternative to that. Eventually you'll drop them altogether, right? And there are people that are racing to this. Are you getting is your team getting pulled into these discussions with operators or enterprise end users that are trying to rewrite topology applications around the way they utilize energy? Are they trying to rip out and replace, or put more natural gas in backup? I think that's the transition. Introducing them as backup, understanding the reliability of them as backup, and then moving them into a primary role, right? We get primary from the grid already, but there's a lot of those grids that are providing us power that are also using turbines in some capacity, right? So go ahead.
And I do think turbines are playing a vital role as well in the complete industry. So it will not be only gas engines, right? So there will be, I think there are use cases where a gas turbine makes sense as well in them. Therefore, I'm going to say, I really be very open at that. So there are, I think, pros and cons on various sides. But coming back to the enterprise discussion, I think it's easier for the moment, at least so far, the experience what I've made over the last, let's say, months or last year is that the data center clients, enterprise clients in the range of 10, 20 megawatt max, grid connections are easier to get, right, so far. So therefore, there's not that need or a lot about bridging. But I think this is going to change as well now. But I think this is, I would say, just the last months, last year, what's going to happen. Backup generation, I think a lot of the... maybe that's not the case in the enterprise, but I need to say that as well. If you're a colo provider and, for example, you're building for a single tenant, this single tenant is a hyperscaler, there might be certain requirements how the backup solution need to look like, right? And that means it could be that even maybe gas would be an option. The clients say, I only want to have it as diesel backup, right? So it could be as well. So there is, what I'm seeing is that a one-to-one diesel with natural gas backup solution does not always make sense as well, right? There needs to be a specific use case. Why do move to a new technology? Maybe in 5-7 years, this could look totally different, because in 5 to 7 years, the industry is aware about the benefits of a natural gas backup solution. It has proven it, and hyperscalers have proven them on a big scale, that as well enterprise clients are going to that direction as well and adopt. But you need to have always somebody who takes it first and bring it to the next level.
I agree.
And that's, I think, very important. And therefore, for natural gas backup solution, I see that is mainly driven by hyperscalers.
Mm-hmm. Yeah, I agree.
Mainly driven by hyperscalers. We are talking a lot about that with them. But bridging solutions are more driven by colo operators and in that regard. But this can change. As we have seen it 3 years ago, nobody thought that we have that grid constraints, right?
Yes.
This can change.
I think there's some people that saw it, but those people didn't have a voice or a platform.
No, exactly.
That's why we have this podcast. This podcast is to have that platform. I want to hear from you. Like, we report the news from the way we see it in the field. I'm in the field, you're in the field. This isn't, I don't host podcasts for a living, and I don't host conferences for a living. Believe it or not, this is once in a year we do it. It's our 9th year. And I do it so I could bring all the big fat brains of the industry together and try to figure out what is the truth, right? Because there are people that say that this is the capability or this is the limitation, and they paint with a really broad stroke. And I have to spend time really scratching the paint with these groups to figure out what the truth is, right? And everybody has I look at power right now as religion. It's very philosophical. It's very spiritual. As an example, where do you stand on nuclear? Do you think that nuclear is going to play a role? And if so, what point and when?
In my opinion, nuclear is going to play a role. Yeah, it depends a little bit on the country and as well how it's going to evolve. I think those small nuclear reactors are an interesting technology. I would say it's very early game, right? There might be some early adopters as well. Maybe
Chernobyl, or not Chernobyl.
No,
what I say, 3 Mile Island.
It was a big one, right?
But you just saw, I mean, like, people are desperate. People are going to go buy
They're
power.
looking at all other types of technology, but the small nuclear is actually an relatively old existing technology.
It is.
Look
it's
at
76
ships,
years old.
and if you look at ships, at military ships, at aircraft carriers or submarines,
I came from a submarine. We had a 26.
Well,
I knew the size
a
of the
shipping
reactor
guy myself, so it's always 50 megawatts or 100 megawatts in there, and this is the concept they want to now put on shore. The problem is, I'm fearing there is on a ship you have operators which are seasoned engineers, etc. They've went through it, they've experienced. You don't get confronted with the technology when you graduate. You get slowly up there and you know how to operate this. I fear that if you have a 50 megawatt reactor there or 100 megawatt there, suddenly you spread it and then you have a problem with the fuel. What do you do with the fuel and what do you do with the people? Because you need engineers for these type of technologies.
Or operators,
or very skilled operators. And this is where I see the danger. I'd rather prefer a big nuclear plant which has processes, how to operate, etc., and that is connected to the grid. That's my personal opinion. But
I agree.
And I think what is an important anchor is it as well in terms of permitting and when they are in operation. I think it's still a certain amount of time. So when we talk about, that's why I'm saying it, gas is going to be for the next years. But yes, gas might decrease then again. Maybe one of the reasons is nuclear power. Depends how it evolves, because permitting and installation of nuclear plants is still not easy, right? So you need to be careful about that, and as well an interesting topic. So therefore, that's what I meant is right. That solutions what we're providing, if I combine that in future with a nuclear plant, I don't see that as competing, right? We can transition in a backup solution because as well the nuclear plant needs a backup solution at the end because there's refueling. It is there, right? There's a certain maintenance to be done.
Oh no, you need those engines to back up the cooling system.
For example, as well.
That's the most critical part is when you hear about these nuclear power plants failing, it has typically something to do with the cooling system failing first. It's the only reason why they fail.
Exactly. And that's why I say I don't see that as competing, but I think this to solve the problem now, gas is a very attractive solution, especially with for example, products like we are producing or as well as selling to the market, but can transition to a renewable fuel if available, but realistically this will all take a little bit longer, but can as well transition into a backup solution, for example, for a nuclear power plant. And that's very interesting, right? So whatever is going to be decided now, it all helps at the end to come up in future with a decarbonization, because at the end, the gas solution is then as well 20 times lower in terms of emissions compared to diesel backup generator, if it is well used either on continuous or as well as backup solution. So it completely decarbonizes it, but it's a totally different solution, right? Prime power, maybe nuclear power plant, backup gas engines, because the grid maybe will not be there, right? So I think that's something what we could envision going forward.
I love it. Well, look, those were some of the questions that were high level, paint broad strokes. This is DCAC Live Week, but I had some questions that I want to make sure that the people that are listening had an opportunity to understand exactly who you are, what you do, and what you see for the industry. And I don't want to bring this home just yet. I want to give you the opportunity to talk about anything else that you really want to talk about. But what are some of the things that, like, if people don't know anything about you, what do you want them to know most about what you're all about? And how can they get in touch with you?
If I might add to, you were touching the topic capacity.
Yes, we keep.
One thing is, of course, the production capacity. How many gensets or containers or modular units can we deliver per year? But what we're doing is we've been fairly successful over the past years is we also have to ramp up our service business, the after sales business.
Right.
I mean, it's not only the product itself. We have to invest
That's
in
all
people.
that I'm in.
What you're saying.
My day job is a tech incubator for labor.
Yeah, and we're actually tripling right now all this in the US, the people we need in order to service these engines, to offer after sales. We're going to do local overhauls. So the workshop is being built up. We're discussing strategies with our clients. Do we have a local warehouse for fairly large plants instead of a centralized concept? All these type of things, but we're interacting with the client in order to define the right service strategy, also after sales strategy for the specific project. We also have certain flexibility there. I think that's an important message as well, because the usual lifetime, even if we're talking bridging solutions, we're talking 6-7 years. But normally the lifetime of such a genset is 20-25 years. So we need to be prepared also for these 20 years.
I agree with you. I think labor is one of the three major components of the existential threat.
People, yeah. Mm-hmm.
Y'all are trying to solve for capacity by solving a power problem.
Yep.
I'm only solving a people problem. I'm going to be talking tomorrow about the obsolescence of college, and I'm going to be focusing hard on the trades and the military.
Mm-hmm.
I come from the military.
Yep.
But I do think that the most advanced weapons and machinery and technology ever built are always first and foremost found within some level of government or the military. Yep. And those people, you don't have to go get a college degree to go to a nuclear power school in the submarine community of the U.S. Navy. But when you come out, you have enough knowledge to where you don't really have to go get anything else. There's a lot of value to that skill set you already had because you're exposed to advanced technology and advanced machines and weapons. I think that we just need to find a better way to open the aperture for those people that are already trained. Your countries have them. Our countries have them. We need to start recruiting a better job from those. Right now, I think we have a bad habit of only recruiting from colleges a lot. And I'm a big fan of saying, why would you recruit from a college where if they were to start today on any element of technology, by the time they graduate, whatever that technology is obsolete. Yep. Try to think about how different of a company you were 4 years ago. Try to imagine how different you're going to be 3 years from now when those people are graduating. That product, that application that you build for, it could be absolutely the same, or it could be completely different. Right. And there's a good chance it's going to change because the market needs are going to change. The market needs change parallel to the consumer's demand of emerging technology. So our industry, the soup's not done cooking. We have a long way to go still. So really what it is it's a function of how much you're willing to invest your time into iterating and collaborating with the operators of this industry that have a product demand and requirement and the enterprise end users, which have a different demand that may have a different reliability requirement or a different scalability requirement, right? But the densities are going to be pretty universal. Don't you agree?
Definitely. And I think that's what it is, right? It is not only at the end we're trying to solve a power problem, as you just said it, but at the same time we need to get the people to that level that this can be handled, right? So it's at the end the education topic as well. And you're right. It will be too late, right, if you're waiting on that. So therefore, we have a lot of cooperations with universities as well and schools that we are bringing the people to the technology already now. So this is a parallel stream that we really ensure that that we are getting the workforce to help the complete industry as well to progress further. I think you know it, right? It's a big challenge, right? I'd say it's a big challenge to use at
Talent
the time.
is hard to find.
Talent is hard to find. It's differently in every country, right? I hear a lot of things is like, okay, how much home office do I have? When do I really need to go to work? It's different discussions, right? 10 years back, nobody would have asked that questions, right? How often do I need to be in the office? But the world has been changing, and we need to adopt as well our industry to that.
Yeah.
In the data center industry, maybe this is more common already, but as well for us, traditional, coming from a power generation business, this is something what we need to learn as well, and we need to live together with that, and really need to develop as well. Let's say the new workforce which can help to go through that. And you ask what is something if we want to say something in addition. I think for me, the most important thing is just one sentence, right? At the end, every technology what we discuss, is it a gas solution, is it a nuclear power plant, whatever it is, it will be all required.
Yeah, because there's no silver bullet.
The problem is so massive, and we just need, let's say, I think as well, not compete, really try to find a solution that we can solve the problem together. Is it, for example, as I just mentioned, is it nuclear power plants in 5 years, wherever it's possible? In the meantime, gas, and then transition to a backup solution, which is giving a complete decarbonization. Will it be maybe at the moment certain requirements, certain nuclear power plants which are running already now, and with power purchase agreements, we see the announcement what Amazon or Microsoft we just over the last months. It will be as well a gas turbine. It will be everything, right? Because the industry is so power hungry.
Yeah,
and
we're gonna throw
it needs to be, let's say, a coalition and not a working against each other, right?
No, this has been awesome. Is there anything else that you guys want to mention before we wrap this one up and bring this podcast home?
Just adding to Thomas, I think the right approach would be team approach, and this team would also involve permitting authorities, because that's also the big problem. It takes too long to permit new power plants, even if the grid would supply. But I agree with him; it's going to be a mix of technologies supplying power to this data center industry or to whoever. It's going to be there in the market.
So I could scratch the paint for an entire hour just on the permitting part of what we're doing. That's a whole.
Yeah, you're living that, right?
Oh yeah,
it's also needed to get this going faster.
Yeah,
because the data center development cycle is not in sync with the permitting cycle of the grid.
So, and not only that, but it's not even in sync with what's going on within the industry. So, I mean, we are so misaligned. Yep. And what's going to make us become more aligned is the demand that we have by the consumers for. They're not going to be happy when we start telling them that they could adopt less technology. They've never had that, especially Gen Z, who's never had that since the day they were born. The most elite and the most advanced technology has been in their hands, and there's never been a limit to what they can have. Now they're going to become limited in themselves, but we're going to have limitations based on power. There are going to be limitations on power. We're going to hit a ceiling somewhere. So, I mean, we kind of saw it in our industry with what Dominion's doing in Virginia, but that'll replicate all the way down through Ohio, all the way to Arizona. So I think now is the right time to maybe bring this one back, because this is a lot of stuff, a lot of really cool and exciting stuff. We're in these early stages. Do you agree? We're going to have more of these conversations, right? Definitely. You're living in Houston. Next time you're coming in from Austria, you're going to have to sit down with us too. But I expect to I'm actually starting a podcast series that rolls starting at the beginning of November, and it's called The Road to Nuclear. And it's just going to be focused heavy. I mean, we're going to be talking about the industry as a whole. We still talk about human dynamics and social dynamics of people and growing people to make them healthier and stronger. Talent is a solution, but we really need to understand power more. So I'm going to be bringing on experts that can help us deconstruct everything from the permitting size to understanding what the limitations are for how many reciprocating engines can I put on one piece of land before someone says, no matter how many permits you have, that's beyond the limit of permittation, because that's exactly what you can do. It's not just the generation, but the transmission of that power too, right? So we have a lot to solve for, and it's going to take a lot of these types of conversations. Do you agree?
Definitely.
I agree.
Well, listen, it's been a pleasure to spend time with you both. Thank you for making the trip all the way over from the pond, and thank you for driving a few hours from Texas.
It's a pleasure.
But you're welcome to Austin anytime to join the revolution. But thank you for joining the revolution, and thank you for showing up on site for the Data Center Anti-Conference. This has been a record-breaking year for us, and we're excited to have you and your support and your sponsorship. So thank you.
And I'm really looking forward to the conference, I have to say.
Me too. Let's go listen to some of these speakers.
Definitely.
You guys ready?
Thanks for having us.
It's been my pleasure, truly.
Yeah.
Thanks, guys.
Pleasure from my side as well.